Write the solution in interval notation. -9 is less than or equal to t. Now we know that 2 is less than 3, and at the same time we know that 3 is greater than 2. Alright? So it looks like you can put the 3 first and the 2 second when you're writing this. You can write the 3 first and the 2 second as long as you're pointing it at the 2. See how this is pointing, the point goes to the 2? Well, the point goes to the 2. Alright? So 2 is less than 3 is the same thing as saying that 3 is greater than 2. But I could put the t first and then the 9. I could put the t first and the -9. But the point of this operation here has to point at the -9. So if we point it at the -9, I could put the t first. Alright? Now, that says that if -9 is less than or equal to t, then t is going to be greater than or equal to -9. Alright? Now, on a number line, what numbers work for this? How about 0? Is 0 larger than -9? Well, sure it is. Okay, so I can darken in the 0. Is -2 greater than -9? Well, just like 0 is greater than -9, we would say -2 is greater than -9. So I can darken in this -2 because it makes it a true statement. All right? -5 is also greater than -9. And you can even have -8.5, and that's going to be greater than -9. What I can't darken in is the -10. -10 is not larger than -9. Okay, numbers that are larger are on the right side of the -9. Now, can I darken in the -9? Can I darken in the -9? Sure. -9 is greater than or equal to -9. That's also a true statement. So, I could darken in everything to the right of the -9 and include the -9. So, when you darken it in, I put a bracket on that number. I put a bracket on that number. Okay? So how do I write this interval notation? Start at the -9 and darken in the -9. Darken in the -9. Okay? And then we're going to go to the right forever and ever and ever, including 1, 2, 3, 4, 5 numbers over here. Okay? So we go from -9 to infinity. This is interval notation for this operation up here, for this inequality.